So we've talked about the fundamental counting rule. Now let's talk about something called permutations. There's actually two different things. One's called permutations and one's called combinations. And with these two, they're very closely related. With both of these, what we're going to do is we're going to select some objects from the total. And we want to know how many different ways we can select a certain number of objects. The difference between these two is that for permutations, order matters. Whereas combination, order doesn't matter. There's no order to it. So, some examples of permutations would be things such as order of finishing a race. Because first, second, third place, yeah, it's going to matter which order you finish it in. Now, the same three people may come in first, second, and third, but it matters which place they come because it matters which medal they get. So, which order they come or they cross that finish line actually matters. Some other things where you think of permutations would be, as we discussed earlier, things like your PIN number. Okay, the order that you put your numbers in actually matters. Or the number that or order that you put your password in, it's going to matter. So those are things that it actually matters what order you select things for. There are other things that, no, it doesn't matter what order. They're all the same thing. Such as just straight members on a committee. Now, I have to be a little bit careful with members on a committee because if you just say members on a committee, that means there's no order. But there is a stipulation where there's members on a committee and they identify president, vice president, secretary, and treasurer. If they are given positions like this, then order will matter. So pay attention to, are those committee members given a position? If they are, then order matters. If they are not, then it's no order. Other things with just combinations are like selecting books. It doesn't matter what order you select books in. Think about going to a bookstore. Does it matter what order you purchase the books or place the books on the counter? So hopefully you get the idea, the difference between permutations and combinations. One is going to have order, one is not. So think about those two things, and then I'm going to show you in the next video how to actually compute and figure out well, how many different ways will there be if it's a permutation versus combination?